Hello, good morning. Is this thing on? It is. Hello? Hello, please. Thank you, please. There we go. There I am on YouTube, and there I am on Twitch. Okay. Let's do some morning game dev. Decided to get a little cheeky stream in before work today. So we got a handful of hours. We're gonna do some game dev, and we're just gonna continue where we left off yesterday with serialization stuff. And so I'm this morning, for about an hour or two, I've decided that I'm going to change my serialize function signature a little bit here. And I'm actually going to be passing in the proxy archive so that I can start writing some specific data type serializer functions and have them be usable. Because I realized, like, I needed to serialize a data table row handle for my items. And that's why they weren't showing up correctly in my inventory yesterday. And I'm already doing another data table row handle elsewhere. So I was like, I'm going to need to do the same thing. And so let's just write a function for that. And I was like, okay, why can't the regular F archive? You know, that doesn't work. I was like, oh, because it's not my proxy archive. Right. So we're gonna need to port that over, essentially. Now, I guess it does feel kind of bad that I have to include this type everywhere, but it does make the code easier to write, so yeah, that's what we're gonna do. And so I should have moved all of those over, and I think I can test. Let's just rebuild. Like, do I have anywhere that I need to fix? I don't know. But yeah, if this ends up working for the items, we'll end up switching over the, what was it? Yeah, this guy right here, the environment item spawner descriptor. We'll switch that over to just use the built-in serializer, and this signature should change as well. Oh wow, but now that doesn't work at all now. Oh, because it's not imported. That makes sense. Can I forward declare it? No. No, I cannot. Okay, yeah, we have a lot of broken places. Yeah, I guess I need to... This is save game object. Can I just forward declare this? Okay. And then in here... Are you good now, or what? Or what? Build that again? Okay, yeah, it hurts. I know it hurts. I know it hurts. Okay, yeah, that makes sense. Okay, now this one is just unbelievably broken. Is this imported correctly? No, it's not. No, it's not. So can I just include... Does that just work? I guess I shouldn't forward declare it here and just import it here, because then by nature everything else that imports a save game object will have that imported. Yeah, so let's do the hard include there. So that should probably fix everything, right? Yeah, so now that's fixed. Inventory component, we can get rid of you. That was probably the missing link. Okay. Still? Syntax error. Why is that a syntax error? Is this writer being bad? Yeah, and then this is weird because I would have to do the inner archive. But I think I need to override the fname serializer here too, potentially. Okay, let me try to resave this. Save game proxy archive, let's go there. Give me the fname. Yeah, give me this. Override fname value return, and then we're gonna do inner archive value. And then that should properly serialize it, I hope. There we go. Yeah, now that resolves. And that resolves too. Cool. We're gonna change that one anyway, but good to have built out. Hopefully everything still works. Okay, we still have the syntax error on save game proxy archive. Why? Why is that? I have it imported. I need to clean up this save game plugin, man. There's so much extra bloat in here from when I was trying to figure out how it all works. What is the issue? What is the issue here? Does not override any base class methods. Yeah, what's wrong with the proxy archive? You know? No longer applies. Yeah, what's the issue here? Save game proxy archive. Are there like multiple of these to find or something? I don't think so. Try again. Do we just need to not have the declaration because it's an interface? I feel like that's not the case. What is happening? Syntax error. What is wrong with the proxy archive identifier? Because it's final? Is that the issue? I don't know. I don't even know what that means. Well, I mean, I know what final means, but just not in that context. I don't know what a final class is. Okay, that things are different now. Different error. That means progress, right? Linker error, wonderful. On serialized. Okay, so we just don't have it defined. So we do want that definition. Return true. Can I make this not return anything? Because I'm never returning. While we're at it, let's just make it void, because I'm never using the return value for that at all. Anywhere we see bool on serialize in my project. Change that to void on serialize. Okay, is that doing headers? Okay, we're gonna need to do the CPP files separately, I suppose. That's what it should be. Cool. What? Oh, yeah. Okay. I'm gonna need to do like regex or something here. What is it? Star? Fuck. Regex. What is it dot? I forget. Is it like backslash dot? Okay, it doesn't like that. We're gonna have to manually do it. Okay, just show me everywhere that happens. No regex. Okay. Uh-oh, did I mess up everything? I did. Oh, shit. Okay, let's fix that one real quick. Didn't capitalize the S. Very, very important. Okay, we only need CPP files now, and we're just going to go through and manually change. Void, that one's good. Void. Void. Oh, we got to delete all the return statements too. Okay. Return. Which is the kind of thrilling content I'm known for. We just refactor everything all the time. Everywhere all at once. Void, okay, boom. We're just getting warmed up. We're just getting warmed up. Some light refactoring across everything in my code base that is serialized. Okay, we're iterating on it though. This is iterating. It's good. This is good. If you tell yourself that it's intentional, then it feels better when you're doing it, right? Like, ah, yes, this is the intention. Okay, well, that's changed. Can we build now? Shit. What? I thought I fixed this. Oh, because it's in a header file? Yeah, that makes sense. That makes sense. Does this need to override? I mean, yeah, I'm getting a lot of warnings in here. Yeah, it doesn't override the base member. I guess we can make it virtual, but like... There's no base function. Do I need it to be? I'll make them all virtual just in case I want to like extend this class, but I don't think it matters. For these warnings, I'm not sure what these warnings are saying to me. This member function has no base class member to override, but I'm not overriding. We did build. We compiled. That's good. We can finally get going. We'll need to resave everything, I suppose, and we need to check the item serialization. Yeah, the inventory stuff. I'll need to go like chop some wood or something. Okay, new game. Spawned. Go over here and chop some wood. Okay, give me some wood. Come on. Come on, hit it. There we go. Thank you. Okay, I have 2 wood. Wonderful. Do the mushrooms work? No, they don't. I shouldn't have tested that right there. That is not the primary objective. I'm going to pay the price for it, aren't I? Item handle. Row name data table. Why isn't that a valid class? Huh. Why wouldn't that have been a valid class? The item handle looks correct. The row name is correct as well. Don't know what this value is supposed to be here. Can we just continue? Please, pretty please. No. Okay, we're gonna have to do all that over. I'm upset. I'm upset. I should probably split this proxy archive file into a CPP file now too, now that it's public. Should I just do that right now? Let's just do that right now. Save game proxy archive. Save game proxy archive.cpp. Yeah, this way I don't have to rebuild so much when I iterate on it if I change some internals to it or something. Okay. There we go. Now we're generating the definition in the right spot. Yeah, it's gonna be a lot cleaner. Move that above. Because this is the one that's like overridden. The rest of them are not. Okay, looking good. There's all this commented out stuff that I don't know when I'm going to get rid of it. It's pretty messy. Pretty messy. Okay, but I think this is better. This is better. So let's rebuild. Who needs version control when you can just comment stuff out? You know what I'm saying? Oh, it wants me to override a bunch of these. Is that what it's saying? No override available. Function is hidden. Objective name as string proxy archive. Yes, they are virtual. Why is it complaining at me though? Don't know. New game? Okay, let's not let's not grab a mushroom. It's apparently broken. Okay, we have 2 wood. Save game. Now the trees are not going to save properly, and that is known. Okay, let's load game. My wood is gone still. Okay. Word. Nothing failed though. Explicitly. So that's positive. Oh yeah, because we didn't actually call the method. That makes sense. Okay, so we're gonna have to redo that all over again. Wonderful. Then I think probably moving the item quantity serialization in here is a positive change. And then I probably need to implement this interface on every class that extends from this, right? So equipment and weapon probably both need to serialize their data table handles too. quantity is serialized, so we don't need to worry about that. Yeah, we just need to do the additional. So we do want to call this super function, but then we also want, what is it called? Oh, there's so much more in this class. Weapon data, I think. Oh, F weapon data. No, that's not it. There's no data table row handle in there. Okay. I mean, I guess the item data can optionally have the data table row handle on it, so maybe it's automatically serialized. Equipment data handle, yeah. Okay, so that can be probably resolved. Let me just do a double check on the equipment class. This one explicitly has the equipment data on it. And it definitely relies on that. Okay, so let's grab serialize there. And then we'll just do super on serialize, and then equipment data equals item data. An equipment data handle. Wait, when does this get populated? Post init properties. I wonder when that gets called. Maybe that'll get called automatically. But I guess maybe we need to populate the item data in. Yeah, when does post init properties get called? Okay, let's put a breakpoint there actually. Maybe we don't need to do any of this. Yeah, maybe this will get called automatically. A breakpoint in both. And then we should be good. No, I guess we'll just need to, we can probably just call that function. Yeah, we can just call post init properties here. And we don't need to do this at all either. We can get rid of that. Yeah, let's hang on. Stop that. Stop the build. I mean, we probably shouldn't be doing that. Okay. Does not override any base class virtual member function. Why does it give a shit? Okay, so the order that these breakpoints get hit, or if they get hit at all, is going to be important. We want post init properties to get hit after the serialize. And yeah, I'm just not, that's too many usages. That's going to be meaningless. Okay, so it got hit already. Oh god, okay, let's turn that off until we actually start the game. And save and stuff. So we'll need to resave. So I'll put that back there. And we'll put that back there when we're loading. Okay. Okay, new game. Then we need to go grab some wood. Okay. Definitely need to work on the physics of the tree trunks a little bit too. Okay, so we're gonna save there. Save is good. Okay, let's put those back. Load game. Okay, so we got post initialize, post init properties. Which did happen after on serialize of the equipment, which is good. Oh, we need to call it here too, don't we? Yeah. So actually, it gets called when it's created. Okay, does it get called again? Post init properties on, this is again the equipment inventory component. Okay. Yeah, so that gets called when the new object is created. Okay, so that's a bit unfortunate. Okay, once again, things are just happening not in the same order that I want them to. So I guess what we're going to have to do is we're just going to have to manually call that again. And that'll make sure everything gets wired up, because apparently that's what I'm using in all my different item classes. My equipment. Yeah, equipment data. And I guess this is just like extracting the data table row handle into a struct that I use throughout the class. Yeah, and weapon does it too. But we're getting the, yeah, we do equipment data, item data, equipment data handle, yeah. Super, and they all call the super first, so that means, yeah, it cascades up. That's good. Okay, so that's good. I think we just needed the, yeah, we just needed the equipment component to settle down. Okay, so, yeah, the items still did not serialize properly. Maybe this is all essentially the same. Yeah, I was talking last night about maybe making that reusable. Maybe I should. We'll see. We'll see. Let's get this working first. Let's get some more wood. And actually, look at that. It actually correctly saved the tree not being there. That's nice. Come on, hit the damn tree. Okay. We got 9 wood. Save the game. Load the game. Oh, now our wood's back. Hell yeah. And it actually correctly recovered the wood that wasn't there before. But perfect. Okay, are we working now? Are we all good? I think we're good. Hell yeah. Hell yeah. Okay, should we commit this real quick? And then potentially make some improvements to it? Let's maybe think about serializing a map of pointers. And let me look here. How does it... Like, if I were to just do AR inventory contents, what does this... this is in the map class itself. Okay. Okay, this is a complicated signature here. Because I would only want to target the cases where the value type is a pointer to a U object. And this is on the map class? I'm confused. Is there like is this one of those friend things? Friend class, tmap base, tmap private friend, tscript map. Fiend. No, friend. I'm confused. I forget how the friend works. It's like for accessing protected methods of another class or something like that. But then how does this get those ones that are on the map class? Yeah, this is just like, this is defined outside of, this is literally outside of any struct or anything, so. Oh, this is just like a global function, I guess? Okay, so I wonder if I did something like this. Let's see. Okay, and so value type, we want this to be like this. I think this is the syntax we want here. I guess, no, we delete that, and then we go value type U object star value, right? I guess we just don't name it. Don't name it. Yeah. So does that correctly target? Does that correctly target what I want it to? No. No, it doesn't. What if I did just take the value type? No, it's still, this one is just like global, and it's just saying fuck you, dude. I will do what I want. The private friend serialize tmap pairs. I bet. Okay, so do I need to target the pairs here? Like, do I need to do the t-tuple or t-pair, maybe? Because what type is that, right? Element set type. Okay, so element type key func set allocator. Yeah, this might be a little bit more complicated than I thought it would be. A set of the key value pairs. T pair. It's a set of T pair. Okay, right. Okay. Key set of T pair. Call that map set. Key type, value type. Okay, get rid of those, maybe? Question mark? Does that target what I want, maybe? I don't know if this is probably not a virtual function here. So we go here, we do this thing, and it's just doing that on an archive, and it's probably... I don't know if this will work, because I don't know that this properly targets it. Well, I guess let's just throw a breakpoint there. Does that actually get targeted? No. No, not at all. Got my nose. I think we need that, first of all. Too many parameters? Yeah, that makes sense. Make it virtual too, why not? Oh, it doesn't like that, hang on. Cannot be template, cannot be virtual. Okay, sure. I don't know why that's the case, but sure. Okay, this seems to be compiling better now. But now the question is, does this actually properly target this function under the hood? Rick Twitch, welcome in. Thank you for the follow, appreciate that. We're working on some serialization today. We've kind of been going down this serialization saga the past few streams here. It all started with me wanting to serialize my procedural terrain chunks so that I could iterate on the world faster for some of my other systems, so I wouldn't have to, like, you know, regenerate the procedural terrain every time I click play, you know. And then by extension of that, we just started serializing everything, because why not? And now I'm just making fundamental changes to my serialization system. Trying to create some of these helper serialization functions, these serialization operators here, to help with that. And so this one in particular, like, there are many times where I'm serializing a map, and it takes a lot of code to do that, because I have to, like, break down the map, essentially, and I have to, like, iterate through the number of elements, and then serialize the key and the value, and create a new object, because the value is a pointer, you know. So I'm trying to make a little helper operator for that, to speed things up in the future, which I think will be really nice. But I don't have very much confidence that it's going to work. So save there. Okay. No, it didn't. It did not. Does it even load properly? No. No, it doesn't. Okay, so that didn't work at all. Yeah, that didn't work at all. It would be nice if I could just, like, override this, but it's just like a global function. I was trying to override this one here for map.pairs. I guess maybe I need the set allocator in there. Maybe. Element type key funcs. Yeah, so let's do key funcs. One more try here. Or I did template type name. Okay, can we try again? We may be able to just click load. Not going to load properly, but we'll at least see if we get the breakpoint hit. Which, if that gets hit, then we're cooking. Then we're cooking. I wonder actually what other serialized functions are in here. Look at this. See, Epic uses the same source control that I use, just a big old comment. But yeah, it doesn't look like there's like a dedicated serialized function for a map. Let's see here. Contents. Yeah, doesn't exist. Good lord, the amount of warnings on this class. Does. Okay. So yeah, let's just load. Okay, I don't think... No, we need to resave. We need to resave. That didn't work. I lied. Okay, one more time. Okay, new game. And I guess I don't need to like chop wood or anything anymore. I can just save once I spawn. Save. Okay, we got there. Wait, why was that? What? God damn it. Okay. Why is that not... Why is the breakpoint not... Why is it not working? I just rebuilt. Why is this class so weird, man? Okay, see, it's not there. Okay, so we're gonna have to get a little more clever here. Okay, UE log. Okay, reached the thing. That's what we need to see. So let's just get rid of the breakpoints because those aren't doing anything for us. God, we're 37 things. Oh my god. Oof. I need to figure out why all these warnings are popping up. Because that's egregious. Good lord, dude. Good lord. Yikes. Okay. Okay, reach the thing. That's what we want to see. That's a different. I've apparently used this log before somewhere else. Okay, we didn't reach it. Okay, so it's not working. All that was for nothing. All that was for nothing. Wonderful. Okay, so let's ditch that. I'm just gonna ignore that. Maybe I can just make a static function. That'll help with the map serialization. So ignore that. Where do I want to put this? Let's just put this in my generic utils, which desperately needs to be split out into into different classes, but we're gonna ignore that now. Serialize map. Yeah, we kind of want that. Give me that back so I can just look at this signature real quick, because I think we're going to want something similar. So I think we only want to do this for maps that have a pointer. So I think value type UObject pointer ref, I think, is what we want. We'll see. I think we have to inline this. And so we will need to so for a lot of my maps, there's only certain keys that I want. So maybe I'll have to filter that out of the map first before I serialize it to make this reusable. If we're saving, and we're gonna do map.get keys, put all the keys in there, serialize the keys. Okay, for each key, type in key, so that should be populated in there. Item class equals we're saving, it would equal map key get class. Call that value class now. Value, and then we do map of key. We're saving value class, and I suppose we need to save the name as well. I don't know if some things are going to need that. Make it a save game proxy archive. Do I need it to be the save game proxy archive? Let's just do archive. I think we'll see if that works, and if it doesn't, we'll go to the proxy archive. Let's also have the uObject outer here to parent these two when we create them. We're saving. Do we even need to do anything? Should I automatically call the onSerialize here? Yeah, we'll see if we'll do if auto save game object equals cast value I save game object. If it is a save game object, let's automatically call the serialize. But I need to pass in like the save game archive. So either I do it here automatically, but what if I don't want to? What if I need to handle it specifically? Because otherwise I'm just going to iterate over them after they're serialized and then do this, which I think is fine. Let's just stick with that. And then we don't need to do that. Okay, and so we would do my generic utils serialize map inventory contents AR inventory contents this. Aha. Okay, so it does probably just want that. Okay. Does it just not want the set allocator and key fonts? Wait, do I need to do that? Tmap int to uObject, not bind to L value of type. Yeah, we for sure need that to be a map. And we for sure, like, that's not the case, right? So why can't my item is a uObject, right? Yeah, it is a uObject. I don't think we want the ref on the uObject pointer. Build match type, key type against blah blah blah. If I put int here, it should be able to coerce that, right? No, it has to be int 32. Okay. Okay, what if I change this to int? It can't downcast the value to a U object? Okay, well that just ruins my whole plan. Okay, C++, pass map into function base class value. Is that possible? So I guess I have to template the value type as well. But this guy says he does it. We have a simple runtime polymorphic solution which uses virtual functions. Yeah, so the value is templated. God, C++ code is so hard to read. C++.com, hell yeah. Okay, let me do this. Value type. But I want to make sure explicitly that this value type is a pointer, is a UObject pointer. So if I do that, okay, that resolves perfectly fine. Okay, so now the question is CPP type name of base class or something. Do I have to do that static assert? Yeah. Is of type UObject. Does that work? Let's see if that compiles. And I'm also going to change the type here to make sure that the error happens as well. Although that's going to change a bunch of things. So I'll create a new map and try to pass it in. Okay, we have an error. Okay, so we hit the static assert, but it doesn't tell you which line it happens from. Okay, let's try that again. Why is that getting hit, though? Oh, this is type name equals, let's try this. And this instead of the static assert. Yes, yes, yes. Build failed, I see. Enable if t is of base, so we want the object star value type. That is a fucking mouthful right there. Does it compile though? It looks like it doesn't. Doesn't. Yeah. Good lord, why is this so hard to write? Okay, so do I keep trying to write this this function? Okay, what else? Can I do something like what is the like accessor that gets the keys and value? Do we even have one of those? Of course we don't. Oh my god. Oh my god, C++ is really going out of its way to be so fucking difficult. Holy shit, okay. I mean, I can do this. This apparently works, allegedly. This allegedly works. I guess I just have to make sure myself that I'm only passing in pointers here. Can I do value type pointer? Yeah, that'll probably fail. Or maybe I can just like... Yeah, this only works with UObject pointers. I'm just going to have to manually myself make sure I don't use this function for anything that's not a map of UObject pointers. Oh boy. What is the type here for this predicate? That's a nasty signature. Oh, they just did auto. Okay, yeah, let's just do auto too. Cool, auto element. Expression result not used. Okay, yeah. Oh god, I hope this works. Yeah, let's just comment out and make sure this works first. Well, no, we're adding here, so we don't even need to do that. Yeah, that's a lot more terse. Can I one-line this? Does C++ have a one-liner? Like, do they have like something like that? No. Okay, let's see if that works. I should probably change that name to like serialized UObject pointer map, just to make sure I don't mistakenly think that that can be just used for any map. Are you fucking kidding me? Oh my god, okay. Because it's a U object. I guess we do value type here. Does that work? And it shouldn't be pointer. Because it already is. Can't convert from T star to U my item. If I put that there. Oh god, this is not gonna work at all. Oh, this is so fucking annoying. Okay, so we're gonna do UObject. Can I just do a value type cast value? We're gonna do a C style cast for value for the value type. Is that gonna work? We're doing a lot of dangerous things. We just gotta make sure it works. We use it right. Nope. No. Oh, we're not passing it. Okay, let's actually do that. Okay, will it compile now? This is like our best chance right here. No reds yet. Okay, I think it's gonna compile. But then the next question is, will it actually work? Okay, we built. Okay. Oh, this is gonna be quite sketchy. All right, start a new game. Okay, let's just let me do one of these boys and let's like shoot an arrow. The arrow is just okay, so now we have 199 for wood arrows. Save game. Stop. It didn't crash. Let me put a breakpoint in here. That's gonna be a weird breakpoint. I don't know how that's gonna get hit. We'll put it right there. So let's load now. What does contents look like? It didn't crash. Contents had... Oh, it worked. Oh, it worked. How many arrows we got in here? Quantity 200. Okay, it did not serialize the quantity properly. Oh, but we haven't actually called that yet. So it's just the default value. So it should... Yep, okay. Oh, it worked. Thank God. It worked. Okay, so we can switch over to using that. Okay, let's refactor this name, serialize UObject pointer map. Okay, so that gets this is going to get a lot more terse for our couple of our classes here. Where's the equipment component? And let's change the contents back to in 30. Okay, it is in 32. Cool. Already changed it. Okay, so yeah, import the U. Now, contents, we're just going to put equipment in there, but we want to do the same thing that we're doing here. Sure, we'll call it contents as well. And yeah, we're just doing equipment value not equal to null pointer. Cool. And call this entry. This will be entry dot value. Serialize. I forgot a open bracket. There we go. And then we're doing add to equipment. Although equip gear entry, maybe add to equipment, equipment.add, either work. But since I think we've got the right thing for equip gear entry, so I'm just gonna use that. Oh, it's looking nice. That looks nice. That's nice and nice. Okay, so rebuild that once again. We'll test that out, make sure equipment is serializing properly as well. We should go like chop down some trees too, just to make sure. Uh-oh. Oh, because it's a T object pointer. Oh. Okay. Oh man. So what do I do here? Can I auto cast? Can I like implicitly cast it? Map of what is equipment? Yeah, give me that. Nope. No, I can't. Okay, so should I rely on these being raw pointers or T object pointers? Okay. Let's just see if that compiles. I feel like the answer is going to be no. I might need to do some more for this. Okay. Okay. Can I convert? Okay, so what if I just made this T object pointer? Still no. Cannot cast from T object pointer U object to T object pointer U my equipment. I'm like 100% certain that yeah, that should be a U object still. Okay. Why can't I cast that? Okay. Okay, and what was the problem before? When I was just doing value type. I think it was still on this line. Yeah, okay, can't convert from U object pointer to T object pointer. Why not? Okay, here's an idea. We do T object pointer here, but then we just cast there. Then I suppose what it's going to say is it can't add it. I suppose that's what it's going to say when I try this again. Okay, so I guess that needs to be now a raw pointer. We need to pointerify it. God, I'm doing so much work just to make it a little bit easier. I'm like sunk cost fallacying so hard right now. It's compiling though now. Okay, and then I should make a helper function for this, for the rest of it. Wait, how would I do this if I wanted to reuse this code? I wonder if I can I do like a type of or something? Value type dot How do I... Is there a way I can runtime check the value of a template type name? Probably not. That seems like something that's a no-no. So if I could, then I could just, like, dispatch this into 2 different functions. So I could do something like this. This is like the normal one. Oh, I need the key. Yeah, key type, key value. And then I need another one where it's t object pointer of type. And then that's where I do this one. Does that work? Okay, does this compile? No. No matching overloaded function found. Christ, okay. Oh, but I guess value type has to be okay. I think I need to add it here as well. Does that work now? No. No, it doesn't. And oh, it's an issue on the UObject pointer one, not the TObject one. The TObject one is fine, I guess. Interesting. I wonder if I could do something like... What if I just did the cast value? This is so hacky. Okay, give me that. Or we're going to do a TObject pointer version of it. And then we return like that. No, but I want it when... Yeah, right here. And we cast a 2-pointer and return as TObject pointer potentially. Is that gonna work? This seems so strange. I feel like this is a no. I do not feel like this is going to work. No. Oh, I need to comment that. Also, couldn't convert to argument types. Now, if I do the... If I only do the T-object pointer version, does that work? No. It does not work for the raw pointer. Fuck. And I can't, like, coerce that, can I? No. Oh, this is so annoying. Does that do anything? That is doing a... That is converting it to a T-object pointer every time. So yeah, that's not going to compile, is it? I would like to be able to... use either raw U-object pointers or T-object pointers. But this should probably just be a T-object pointer. Okay, let's just bite the bullet. We're gonna switch that to a T-object pointer, and then we'll just need to make sure, moving forward, that we're only serializing T-object pointers. Okay. Yeah, I could have two different versions of the function, but I don't want to have to copy the code. Get content, so this has to be a T-object pointer as well. I don't like T-object pointers. That's kind of annoying. But see, it can't be blueprint callable. Okay. That's why I didn't have that as a... Oh my god, that's why I didn't have that as a fucking raw pointer. Oh my goodness. Okay. We're gonna have two functions. Fuck it. Okay, is everyone happy now? Can we move on? Okay, I'm gonna run to the bathroom while that one builds. It's gonna take a while. Okay. We built. Now let's make sure this still works. We'll need to start a new game. Start a new game, go get some wood, change my equipment, make sure all that loads back in the way we left it. Okay. Save, load. Okay, new object called with invalid class. This is equipment, mace, bow, arrow. A null pointer class object. Equipmentry.value. How is that a null pointer? What? It went from here, where it is very clearly not null, to here. I'm even checking if it's null. What happened? Oh, it's a T-soft class pointer. Oh. Oh. Yeah, okay, we're using the wrong function there. Yeah, I need to use add to equipment. Right? Reverse the key and value. There we go. Okay. Wait a second. Am I doing that in the wrong spot? Hang on. Yeah, I think I'm doing that. I don't think we want this anymore. Restart again. Because init new equipment component happens post initialize components, which we wouldn't have any equipment at that point, I don't think, if it's working correctly. Okay, so the save should still be valid, I believe. Maybe not. Yeah, let's resave. Man, dude, the world, if Unreal Engine booted instantly, would be just futuristic. Okay, new game. Let's go get a tree. Save. Load. It loaded great. Oh, wonderful. And it actually equipped the bow properly, too. What happens if I save with this? Is it still going to have the bow equipped? Save. load. Is it going to equip the axe or the bow? Probably the bow, because it's second in the list. Okay. I don't know that I care about it. Okay, this is finally working. Now, one thing I want to do here is archive item handle, just like that. And this is a header, so we do have to rebuild. But we want to make sure all of the ISMCs are loading properly, because we did create the data table row handle serialize operator. So that's good. Okay, so just one more test to make sure it works, and then I think we commit what we have and we move forward to serializing the ability system component. And then, what do we care about anything else right now? I mean, I feel like we might as well just like get through that list of shit to serialize. Where is that? Yeah, inventory and equipment. We can cross those out. New game. Yeah, we gotta start a new game. We'll go over and chop a tree down. It will be nice to see that the tree gets serialized properly as well. It's all coming together. It's all coming together. Okay. I need to fix my auto attack, because now we're just stuck auto attacking. Okay. Yeah, so that's very slowly falling. That is light as a feather, isn't it? Okay, let's save game. Let's load game. Hopefully everything spawns properly here. Tree's gone. Tree is gone. That's good. And yeah, we seem to have everything. So I think we're good. I think this is committable. Should maybe fix picking the mushrooms. What would also be nice would be to get like a world selection screen as well, or like a save file selection screen on the main menu. Now, I think that would be nice. And that way you could have different seeds to test with and load from, and I wouldn't have to like start a new save every time I switch seeds, because right now there's only one save slot. Okay, everything looks like it's working here. Yeah, that's looking good. Sick. Okay, let's commit this. Oh my god, UE5 files. Okay. Serialize equipment, player, equipment, inventory, and implement some serialize helpers, essentially. Hi, buddy. I need a doggo cam. Okay, commit that. right, so now next thing, ability system component. And a lot of this, I think, is going to get stood up on its own. Now, things like cooldowns. That's an interesting... Do I serialize the cooldowns? I mean, I suppose you would want to, right? Especially for long cooldown. Where are these used from? I wasn't even in the right class, that's why I couldn't find it. You cooldown time remaining for handle. Cooldown. So it's using start world time. I wonder what the conflict is going to be. Like, let's say I do serialize these cooldowns. When I load back up, let's say I have a 2-minute cooldown, but I save and then load 30 seconds, you know? Is it going to be the same as when I saved? Or is it going to be the 30 seconds later? Do we, I guess I'm asking, like, do we want cooldowns to continue to cool down when the player has saved the game? I'm going to say, for multiplayer, I would want to say yes. But for single player, I would want to say no. Continue to cool down. Whoops, okay. Yeah, because like for single player, the world, if you save, the world's not going to be going while you're gone. But if you're multiplayer, the world may continue may keep going if you're not like the server host or whatever. Depends, some debuffs you might want to keep. Welcome in, Marcus. Yeah. Yeah, buffs, debuffs. I think I would, yeah, it's, I don't know, it could go either way, right? I think single player and multiplayer, single player, like, definitely no, right? Because then that would just be, like, unfair. You could just save the game in the middle of a fight, wait 2 minutes, come back, and you got your cooldowns back. But for multiplayer, you know, it's different, which is kind of weird. Let's just, I'm gonna say I would prefer it to not continue ticking while your player is gone. I think that is the best choice for both worlds. But I'm not super worried about getting the cooldown serialized. There's also current target and aggro table. Both of those are going to be important for NPCs. Ability modifier handles. That's where I'm putting the talents in. Do I have a different... New ability modifier effect. Forgot where I'm storing the level of talent. Oh, here we go. Ability modifiers. So I think I can recreate this one. Yeah, I built this whole ability modifier system to handle talents and stuff within gas. And I think these are for like the active ones, right? This is for like the things that are like, oh, increase crit chance by 5%. All right, that's just an infinite gameplay effect that gets applied. A lot of them, though, are not gameplay effects that get applied. They're like situational type things where it's like increase fire damage by 5%. So it only applies on fire damage. Or increase fire crit chance, or increase crit chance of abilities A, B, and C, but not D. Yeah, I'm just going through my ability system component and trying to figure out what I would need to serialize. Active buffs, that would be one we'd want to save too. Load abilities, that happens, that's gonna happen each time. Okay, I think that maybe entity might be one as well. Although I haven't gotten to serializing the entity system yet. That's going to be a whole can of worms. So I would definitely hold off on that one. I'm wondering if I should create like a little struct to just hold the serialized stuff. Kind of keep it separate from the ability system component. Although I'm not, what would that, what benefits would that give me, other than just some modularity? I don't know. I don't know that that would grant me anything. Okay. Okay. So, faction. What do I do with faction in here? Literally nothing. I reference it in other things. Okay. I do have save game marked on it. But it's also just getting set and begin play and stuff like that. We won't worry about faction now. I'm not really doing anything with that. Go back up here. Okay, so first off, current target is not going to work. Yeah, I guess this is where I need to dig back into the redirector. That's going to be a pain in the ass. Do I care about doing that right now? I don't know if I want to get into that right now. That's just going to be a whole rabbit hole. Because I'll need to, like... The pointers that I want to save, I would need to, like, spawn those pointers and redirect to them and stuff like that. That's just, like, a whole thing. Ability cooldowns. Yeah, I don't know. Nothing in here is too important to serialize right now. I think maybe I'm just going to skip this. We're just going to do nothing. We'll stub the function there and do nothing with it. I think the inventory and equipment were more important than this stuff here. What else did I want to serialize? Colonies and quest log. Yeah, also not important. Okay, let's just call it good for now on the serialization, actually. I don't want to get into all that, because that's just going to get really complicated. Save game proxy archive. Yeah, I'm going to need to handle these redirects and stuff, too. Yeah, I'm going to have to dig back into getting this working, because that's what I was doing for redirectors. Okay. I don't really care if I need to iterate on talents a lot more. They work technically, but I only just have a few just for a proof of concept, so I'm not too worried about it. About getting those saved for the player at the moment. Okay, so I think our serialization journey is at a conclusion for now, which is great. And so now we can probably move on to what, voxel data? So that we can get these trees, prevent these trees from spawning underground. I'm saying voxel data. But it's really going to be vertex data, I suppose. That's done. Pretty sure this is done. Okay. That's done. This I have async PCG. Okay, here's have my serialization and cleanup. That's done. Okay, yeah, we need to come up with some vertex data from our compute shaders. Now, two different ways I could do this. And it's either during generation or post generation. Now, the reason I wouldn't want to do it during generation would be that it's just kind of shoehorning more stuff into the compute shaders, and I only have one thread to run the compute shader stuff on. So I kind of feel like I'm somewhat running out of resources there, especially if the player's GPU isn't that great. But it shouldn't actually be too much. But I guess it is. It's just the thing that's worrying is there's an additional extract buffer pass, and that does take time. But it would be easier to do it as a part of the spawning process or the generation process. There would be a way to do it after the shader has generated all the data. Because I do have the output data from the shaders, and I can just kind of query that data for each vertex and see which one it matches up with to determine, like, is this underground, is this height map, is this 3D noise vertex, what material should be on here. Although I would think that, so eventually I'm going to need to get to ore, spawning ore in places. And I'll need to think about how I want to have that represented in the data. I suppose there's a world where I could bake that into the material. That's an interesting thought. So the material that we're looking at right now, it's just a landscape auto material. That just kind of automatically gets put onto the terrain, and then it just displays based off of you know, like the slope and the height. I could write some material graph in there to, like, I could pass in the world seed to the material graph, and I could, you know, I could do a bunch of noise generations for each, like, type of ore, right? And there would be a way to do that. Now, I guess the downside of that is that if I ever wanted that to be, like, dynamic and stuff, for, you know, maybe some biomes have less ore of particular ores spawned underground and stuff like that. If I ever wanted anything like that to happen, I would need to start passing all that information into the material, and then the material just gets, like, really complicated. And I'm not that great at material graphs. And so I feel like for scalability, it would be a lot easier to just write it in the compute shader. Not that I'm great at compute shaders either, but I feel more confident in them. And I already have, like, the biome information and the noise parameters already passed into the compute shader, so it's kind of already set up for me to do some underground blending, which I'm already thinking that I'll need to get into at some point. And if that's the case, how am I going to represent? Let's think about representing ore in like marching cubes or the 3D noise. So this is my 3D noise. I got cheese noise and noodle noise. Yeah, I mean, this would be the ideal location to put the ore at. I suppose what I could also do is just use PCG to spawn ore. What is this? Oh, it's just not spawned. Because, like, you could imagine this as being ore, right? And so I could use static meshes for the ore. And that would make it to where I wouldn't need to put any ore data into the Vertex, like Voxel data. I kind of like that. Use PCG to spawn the ore. Yeah, and then each biome can have its own ore spawning process. Now, what if I wanted to reuse the ore spawning? I'll just have to find a way to do so. Potentially, there's a couple different graphs. Yeah, potentially there's a couple different graphs. One for, like, underground and one for, like, height map stuff. I do the surface sampler node and then just filter it for underground points and above ground points. And split those off into different graphs, maybe. And that would happen for every PCG component, maybe. And so there would be like one parent PCG graph that kind of like splits off and queries some different generators that get passed in. And then that way we wouldn't run the surface sampler multiple times when we don't need to. Because that is, it's a non-negligible amount of time. I'm seeing it take like 8 to 10 milliseconds for each chunk to generate just the base points. So it's not too bad. And it happens async, so it's not too bad, but definitely being considerative, or definitely considering performance there is a good idea. Look at this little tiny hole here. Come through this tube. Little tiny pocket down in here. And so, what data did I want on the Vertex data? Essentially, I just need to know like what noise it came from, the Vertex. Did it come from the 3D noise, noodle noise, you know, cave noise, or cheese noise, or did it come from the height map? Oh, look at this little guy. That's funny. Yeah, we're gonna have some grass hanging off the edge. That's fine. I'm not too worried about that. Yeah, so I think I want to do this as a part of generating the data. And that would have to be done in marching cubes. Well, unless I wanted to... If I did it in marching cubes, I wouldn't have whether or not it came from noodle noise or cheese noise. Out noise is just a float right now. I could make it a struct buffer, which I hate fucking working with structs and shaders, but that way I could assign noise, the noise value, and the where the noise came from value. And then that gets passed in here. And there would be an additional output. Because we have the height map noise as well. Which, let me look at the height map. Maybe there's some more information we can encode from the height map. And I think I need to think about terrain deformation as well, because there's going to be new vertices created when that happens. And so I could either have all those new vertices inherit, you know, the vertex data, of the old ones, but then there could be conflicting data there. So it's like, how do you decide which vertex gets which noise values or vertex data values? Dead tick welcome. Thank you for the follow. Hello. Yeah, we're talking vertex data for our procedural terrain generation. trying to figure out how I want it to be encoded. What OS do I use? Windows. Yeah, so there's also a lot of data in the height map. Although I guess I don't really have... I wouldn't really have what, like, if it's a mountain or not, right? And for the noise blending, would there be any information I could extract there that I would want? I could provide the weights of the noise blending. But that seems like a lot of data for not that much benefit. So maybe I just say whether or not it is a height map or not. And if I wanted to like rely on like, you know, is this a mountain or a border or whatever, maybe I would just rely on the normal of the point for the slope. Okay, so I guess the thing that's worrying me the most then is just is the post deformation vertex data. What would I do there? The material would handle it fine, but then what would the new data be? Would I just make it empty, like it's deformed terrain? Because really I just want that data for PCG right now. The material handles it fine. Although I could pass that information to the material as well. Yeah. Yeah, and then I guess I would want to think about what kind of physical materials I would want underground, if that's ever a thing. Yeah, this is all making me think that I need to just voxelize the data entirely. But then that would mean storing a lot more data than what I have now. Right, because I do think I would want to know for like crop planting and stuff like that. If we're planting it on dirt, you know, maybe there's some soil fertility mechanics as well. And so if a player were to like just start digging, you know, what material would they hit? I could encode that entirely in the material graph. And then just try to, and then I could pass in the vertex data and then just kind of roughly base it off that. Then I guess I would just need to come up with some noise in the material for like what the physical material is at any location. That seems a lot easier to use at render time than it would be to like encode all that and keep it in memory. But then what's going to happen when a colonist you know, digs at a you know, a chunk that's not actually generated as a mesh and therefore doesn't have a material? I can queue up a material and give it some vertices and you know, wire up the parameters and like get some output from it. So that would be possible. That's kind of clunky though. A lot clunkier than just having the material rendered and then like getting the hit result or something, you know. Okay, I'm gonna write a few things down. So voxel data. So I think so this is like options. What noise the point came from. Voxel data, I'll say / vertex data. Let's say or what to do about what to do about physical terrain material. Not to be confused with Unreal Engine material graph material, although I think I'm going to do it with that. So I'm going to say let material graph decide per vertex. I'm also planning to do some kind of cool things with vertex paint. And so I think that would interact here pretty well, right? Like I'm imagining some fire abilities, you know, putting, instead of having to use like a decal or something, literally painting like a burn mark onto some verts or something like that. So that'd be really cool to actually encode that vertex data there. Some cool stuff you can do with that. And I want to have like a bug race, like an almost a StarCraft Zerg race that spreads creep. So I want to be able to paint that onto materials and stuff too. And so that potentially needs to go on the vertex data. Or options are spawn with PCG, generate from noise in shaders, generate from noise in material graph. And then I need to make considerations. If I can considerations for grain deformation. It is nice to get the vertex data from the material on it, but when NPCs hit terrain, when the mesh is not actually generated, we would need to what would we need to do? We would need to like enqueue a render command to get the data if we needed to. So, kinda clunky. Yeah, so we have some options here. Considerations for, the terrain deformation. What would be cool is if I could somehow get my compute shader functions to be material expressions as well, which means like show up as nodes in a material graph. And then I may not even need to save that data. I could just let it calculate. And so that would save on memory. I don't know how difficult that would be though, or what I would need to change. I have no idea. that material expression stuff, I have seen some of it in the engine code, and it is a bit complicated. Theoretically possible, right? Because one of the functions I'm using is a built-in Unreal Engine material expression, the noise function from the material graphs. So it would be nice to have some interoperability between those. Yeah, so there's this whole saga I can go down about underground noise settings. I guess in a game like Minecraft, they kind of use the same noise settings for underground all over the place. And they don't do it like per biome or anything, so... Right now I don't have per biome underground noise, it's all the same noise. And so right now, how to handle different biome noise. Right now there would be no difference. I think the cool thing about spawning ore with PCG would mean that I can spawn some on the surface, which I think is something that I want to do. I want to spawn things on the surface and have them stick out. So that would be easy with PCG. Now, what would be kind of weird for spawning ore with PCG is if you get to like a section like this. Show me some blobby noise. You know, you get to a section like this, and it's like they could just be floating in the air, you know? And well, I guess I only have the vertex data. So spawning them in PCG, I only have the vertex data. I guess there is a world where I can just use a volume and spawn them in there without collision or anything. But then I don't know if I'm spawning them in empty space or solid space. Unless I have voxel data. So that is actually a little weird. So ore and the physical material of the terrain are somewhat similar. Yeah, and if I want to have terrain deformation and like digging the ore, yeah, I guess I need to think about how that's going to happen when the world isn't rendered. That's going to be kind of difficult. I'm going to need to do a lot of stuff in the background. Having the ore and the physical terrain material as two separate things, I think makes it a bit easier, actually. Because otherwise, if they're baked into the same thing, like let's say I'm doing both through the material graph, then I'm going to need to query the material graph every time an NPC hits the material graph. And I'm going to need to, per vertex, decide which vertex are getting deformed and which ones aren't, because you would want different like densities, right? Different deform rates of ore versus, you know, just dirt. Yeah, ore is going to be complicated, man. Spawn with PCG. How would I determine where to spawn? Could use a 3D volume, but then what if I spawn floating or veins in empty space? I would need to determine empty space versus solid space, which would require the voxel data, which means more memory. But if I had the interoperability between the compute shader and the material graph, I wouldn't necessarily need to store it, because then everything would just kind of go through the material graph. Investors? Possibly you. What do I want to say here? I want to write down something like, if I made the compute shaders functions into material expressions usable as material expressions as well, we wouldn't need to store the voxel data, but we would still be able to access it at runtime via the material graph. Now, I guess the question is, how complex is this material graph going to get? And can the GPU handle that? Isn't there like a view for like room? What the fuck is that? Visualizers. Show. Where's the thing that shows you like how terrible your materials are functioning? Visualize. Shading models? Is that? Shading models? Oh dear. Weird. Okay, what is this? Okay, that's not what I was looking for. That is an interesting view. I have no idea what I'm looking at. Buffer visualization? It's like, isn't it called like material complexity or something? Material complex shader complexity. Okay. This is what I was picturing. Okay. Okay. So bad. Okay, bad. Got it. Okay. It's weird. Like, is bad that bad? Is bad that bad? Because, like, it's not even in the middle. So, How bad can it be? Extremely bad. Yeah, it's not even... How bad is bad? Maybe I can search for that. Unreal Engine. How bad is material complexity? No, shader complexity. Why do I have a dog hair stuck between my teeth? Does landscape shader complexity really matter? It only counts instructions. Crazy Cowboy, hello. Welcome in. So this is, the answer is really like, it depends. Which is a fantastically ambiguous answer. And I have a feeling that my shader complexity of my compute shaders are quite high. But I guess it would only be running... It would be running per vertex, so... That wouldn't be too bad. Because my marching cubes will run per... It runs like per 3D voxel, which is, you know, a lot more than what actually ends up getting used as a vertex. So I can picture what I want in my head. How badly would this affect rendering performance? And this would... I wouldn't store the voxel data, but I would still need to query it if I were to need it. And I still wouldn't have it for PCG. So spawning ore with PCG is looking less and less likely. Let's update my title to something. Voxel or Vertex data? That is the question. You know, how much of this data do we store? Do we store any of it? Do we just rely on it to be generated at runtime? How does that affect performance? I feel like memory is my bottleneck right now. My rendering performance, I feel like, is quite good. Especially, I'll be using nanite for, like, as much as possible. How badly would this affect rendering performance? So I guess the question is, am I going to store any of this in memory? I would still want some of this data in PCG, so... I need some sort of data to determine what the vertex sampled points represent. But I would only need that like once. I wouldn't actually... I could get rid of that data after PCG spawns. Well, then I have to think about respawns. That would like resample the Vertex data. But I guess I could tie it all together in that node that I wrote for the surface sampler node. Could toss this Vertex data after use, but when respawning, we'd need to regenerate it when the PCG graph reruns. Querying this data, querying slash generating this data could be done inside of the chunk surface sampler node. Which, if we were doing everything through the material graph, I guess we would just enqueue a command for that. Yeah, I'm trying to think of what that would look like code-wise, because I have used materials to write to textures. I know how to do that, but I don't think that's what I would do here. I would need like how it's if I'm just doing for one vertex, I think it would be rather simple to just pass in the vertex location, right? Run the graph on that and get an output for just one vertex. But I think a lot of this would be like for a collection of vertices. And so would that just be the UV data? I guess I need to understand more about how rendering works and how material graphs work. I am still somewhat new to that side of game dev. Like when you apply, I know when you apply a material to like a mesh, somehow the vertex data and UV data gets passed in. Kind of that happens automatically. How would I do that manually if I don't have the mesh? Because I do have the vertex data and the UV data is easily generated. Unreal Engine. Material. Pass vertex data to material shader. Well, this guy's doing the same fucking thing I am. Working on a procedural infinite terrain with some noises. Oh, he's just talking about biome weights. But how would I want to like effectively spoof the mesh. Have you seen Threat Interactive's video about all the downsides of Nanite? No, I have not. I've also not heard good things about that guy. People on the Unreal Engine subreddit do not like him and his takes. I understand Nanite is quite controversial, though. Let's just, let me just look up like a vertex data in material. Sure they wouldn't like him. Yeah, I think I forget what exactly they say about him, but I think it's something along the lines of like him just like bashing a lot of things, and like his takes are like kind of unfounded, but not super valid, I suppose. I never heard of him before that though, so. Also unfair to compare a new tech to decades of optimized workflow. Welcome in, Namrock. Yeah, I mean, in some ways, for sure. But like, how else are you going to describe it? You know what I mean? Like, you kind of have to compare it, but it's not like an apples to apples comparison. So, yeah, Crazy Cowboy. That's kind of what I'm saying. Like, I think there are some ways that it is unfair to compare them, and then there are ways that it's fair to compare them. Like, Nanite, you definitely need to understand how to use it from what and I don't. I don't understand how to use it, so it sounds like there's a lot of caveats and a lot of situational things that you need to know about for Nanite. And so to just outright say it's like better or more worth it than, you know, using LODs and whatnot is unfair to say. Let me just look at a material here. Chunk material. How can I just get data out of a material, like, onto the CPU? I know I can write it to a texture. But that's like 2D information. Yeah, I guess what I need is I need to be able to pass in some world locations to a material and get some value out of it. What even value would I expect to get out of that? What is chunk material? Material instance dynamic. Yeah, I have no idea if what I'm describing is even, like, natively possible. Vertex normal world space node. Yeah, but how would I get vertex data out of a material? Within materials, blah blah blah, but I want to get it out of a material. You'd have an easier time making a mesh specifically for it. think the easiest way to do this would be to just set up a Niagara effect that spawns a particle at each vertex and sets its color by sampling the mesh vertex color. Okay, so that's an interesting idea. Yeah, Epic definitely should do a better job of explaining what nanite is, but you know, it's all, the marketing is very strong around nanite for obvious business reasons. But unfortunately, we have to rely on community people to tell us about it. I don't think there's a whole lot of unbiased Epic documentation or talks on it. Prosto, welcome in. Passing custom information into material from procedural mesh. Yeah, okay, so I can pass it. Yeah, I can pass in all the vertices into a Niagara effect. I have some experience with that already for the spline data. What's with voxels? Yeah, so we're talking about, let me get this ugly thing out of here. I need to encode some data about my terrain into some data format so that for a couple different reasons. One of which is for spawning PCG, because you see I have all these trees spawned underground. Don't want them spawned underground, right? So I need to like mark all the points as whether or not they're underground or above ground. One reason. Another reason is going to be for like the physical materials underneath the terrain and stuff. Yili, hello. And so if you were to deform the terrain, you know, what's underneath this rock right here? I need to encode that somehow. And I'm trying to think about the solutions for that. And I was kind of asking the question, like, maybe I should just, rather than storing the data and taking up more memory, memory is kind of a really important resource for me. So I'd rather not take up more memory if I don't have to. And I don't exactly have voxelized data. It's like per vertex. So there's some conflicting considerations between those two concepts. And so I was just thinking, I was pontificating upon whether or not I should try to like encode that into the actual rendered material and not as a part of my compute shaders that generate the terrain shape, and let the material decide what the terrain is made up of, which it already does to a certain extent. I have this auto material on it, but I would want to take it further, and I would potentially want to, well, no, I would need to take my compute shaders and I would need to make sure that their functions can be exposed as material expressions as well, which would potentially increase the complexity. Well, it would definitely increase the complexity of my rendered material, but you know, is that okay? Is that too bad? Does it affect performance too much? You know, I don't know. And then also, what do I do about all of the terrain chunks that aren't actually spawned as meshes, right? And I have entities moving around on them trying to deform the terrain or do that, or that would need some of this data, right? Like there's definitely a way to get data out of a material. I have done it by rendering to a texture, but that's just 2D data, right? So how would I get the per vertex data out of a material onto the CPU so that I can work with it? That's what I'm trying to like figure out right now. And in this thread, someone was like, what did they say? Something about Niagara. Yeah, spawn a particle at each vertex and sets its color by sampling the mesh vertex color. I don't know. I don't have a mesh. I guess I would just be like spawning a fucking cube or something. Sounds like a weird way to do it. Yeah, I'm not sure that there's a not weird way to do it. If you're doing voxel data, then you would need to build your mesh based on voxels, right? Yeah, so it's kind of like half built on voxels. Like I do have marching cubes going. So the 3D noise is voxelized. The height map is not. And when the player deforms the terrain, it's not voxelized. It doesn't like adhere to voxels either. So I would rather have like a per vertex query so that I wouldn't even need to store the voxel data at all. Because like if you think about it, I really only need the surface data. That's all I need. I don't need all of the internal underground data until we actually deform our way there, you know, dig through the terrain to get there. And once you have experience with Nanite, I'd be interested to find out your opinion from first-hand use. I'm not an Unreal dev, I use Unity and Godot, so I don't really have any first-hand experience. Yeah, I'm not, like I'm a software engineer, so I have no, like the rendering side of things is still completely foreign to me. So even if I do get some experience, I'm not sure I'm gonna be the person to listen to. And yeah, if I just had every mesh built, then I could just query. I like it wouldn't be difficult to get the material data. But these meshes, there's not actually meshes here. Like there's not meshes here that are set to invisible. There is no mesh. But I'm exporting custom navigation data. That's why the nav mesh is showing up there. So if I have an entity out here trying to dig, you know, I can deform the verts myself. That's not a huge deal. I know how to do that. How about storing a 2D height map? If you only need surface or not, then if vertex below height map, it's underground surface. Yeah, I do have the height map stored. The problem is, how do you determine what the physical material of the landscape is underground, right? Right now, that's just defined by the material, which is why I'm thinking about it, right? Like, right now this is sand, but I should change it. If this were dirt and this were rock, when you're deforming the terrain, you'd want those to react differently when it's being deformed. And so I would need information as to, like, what is the physical material? Not just, is it underground or is it on the height map? I do want that information as well. But I also need just, like, the physical material of it. And then when we extrapolate that thought to, like, ore, right? You know, you have copper, you have iron, you have all these different ores, and you want to like gamify that. You need to know if we're, you know, when we're digging, if we're striking ore or not. Material index property per vertex. Yeah, how does that work? Because like I would also need to, I guess the part that's like I know I can have that when like the mesh is already rendered and I have a mesh that has a material applied to it. But I don't. Like everything that we don't see, there's no mesh there. So how do I use a material and pass it vertex information and then get vertex information out? Don't know how your engine works. I don't know how my engine works either. God, I wish there was someone who did. But in what I'm using, I can define vertex structures. What are you using? Like, I know I can pass in UV data. But but that's not exactly going to give me the per vertex data that I need. First, check what tools you have. I think I'm a little past that step of figuring things out. I appreciate the tip, but I'm looking for more targeted advice in relation to Unreal Engine systems. I can't exactly look at Unreal Engine and be like, oh, what tools I have to support my super duper specific problem. There was not one that's going to be like, oh, hey, yes, this is the one you should use for that. It's a little bit more complicated than that. And it's not like Unreal Engine has the greatest documentation for the tools anyway. Pass data to materials via scene uniform buffer. Passing a single float value. Passing a data table. Okay, what is this? What is the scene uniform buffer? Let me open up a material graph here. Just grab this one. Let's just look like get data out of material. Materials read values, they have no output of any kind. But you can't, there are ways to do it, so that's false. Yeah, draw your materials or render target, then read the pixels. Yeah, I've done things like that before, but how would I do that, like, passing in? I guess what I could do is something along the lines of, like, you know, have an input for vertices or vertex data. Maybe there's probably like some built-in input I can use for that. Per vertex data. That way it lines up whether I'm rendering the mesh, using the material to render the mesh, or if I'm just using the material to query some arbitrary data. Input some vertex data, which is essentially just going to be some world space vectors, and render it to a render target, where each making sure that the material graph works by outputting, like, I would have to like put like base color, put like the per vertex data in there, and I would have to make sure it's a vertex space shader, I guess. And then if that's the case, then would each pixel in the output render target, would that relate to each input vertex that I put in there? There should be some basic tools, API you could use. You for sure know your engine better than me, but I don't know how to solve this issue. It's either you don't know what it can do, or there's no such possibility. Check API, it's just a general advice. I'm using a different tool, and I know how I would solve this, knowing my possibilities. Yeah, unfortunately, Unreal Engine is a very complicated tool, and it's not... they don't have the greatest documentation. Looking through the API docs would take eons, and it doesn't exactly... It's I don't know how else to say. It's not that straightforward. I wish it were that straightforward. But yeah, I think the answer is the docs are not that great. They're not great enough such that You know, like if they were good enough, me searching how to, you know, input vertex data and get output data from it, from a material, would show up as a part of the API docs would be a search result there. But they're not, because the API docs are just not good. And so I have to rely on searching for similar problems. How do you want to use this data and where? So one is I just need it to render. So I just need, which is, you know, that's easy. That can just be built into, that's what the material graph does. I also need it in on the CPU. Essentially, I need it in PCG when I spawn points so that I can stop putting trees underground. I would need it whenever terrain deformation occurs, so that I can determine how the vertices get deformed. And that would need to happen. I mean, I guess that wouldn't necessarily need to happen on the CPU, but it could happen on the GPU. But inevitably, I am going to need some output data because I need to deform the mesh. PCG can't return data. So PCG doesn't have access to the data that I need to give it. I need to figure out a way to give it access to the data I have. Or I don't have the data yet. That's what I'm trying to figure out, how to get the data to all these different systems and what form I want to store it in. That's why I'm asking these questions. Getting variable out of material editor. Yeah, a lot of people responding don't know what they're talking about here. Well, it's just making it this guy knows what he's talking about. Yeah, I guess there's no other way to figure it out other than to just try. Yeah, how would I pass in the vertex data? So let me go back to this. Like, there is like vertex normal world space, vertex tangent world space, interpolator. Oh, that goes from what's the other pixel interpolator? Yeah, so I think this is the kind of thing. Let me learn about this node.
Vertex normal world space.
Sure.
In this video, I'm gonna explain what it is, what it's used for, and how we can use it in our materials. By the end of this video, you'll be able to create a pop-up, but they're the same. It only has one output and no settings here in the details tab. This section here adds a description to the node. All the nodes have it. We can also right click on the node and add the description here.
Okay, this is stupid. I don't need that information.
To better see the colors. It's easier to understand if I use a mask node and check its individual channels one by one. So add a component mask, connect them like this, and only enable the R channel. The R channel represents the x-axis, so we'll get the in the middle, and the normal in the middle is in the form of a vector. These are the normals. In the z-axis, the normal on the top is 1, the normal on the bottom is -1, and the normal in the middle is 0. Here we have all the values between 0 and 1, and here we have all the values between 0 and -1. 0 and any value
I don't
below
think
that
this is going to
black.
tell me what I need
That's
to
why
know.
this part
This
is
is
black.
like surface level data about the node. I need to understand like how the data gets there.
To local space. Connect it like this, and it's done. Now no matter how you rotate the object, the mask won't change. You can also add the component mask after the transform vector node to mask any channel you want. Multiply and add node.
Yeah. Yeah, so if let's just say I had like an input, it would just be like an input texture, right? The texture would be my array of vertices. And then I suppose I could do something like that or something. I guess I would need some material functions to translate between the render version of the material graph and the query version of the material graph. Okay, but if I had an input texture that were my array of vertices, and I were writing it to a render target, and I had like I would need to pass in the world space, that would be the vectors, so they would be in world space. I would need to pass in the world seed as well to like run some noise generation off of. I would need to have my compute shader functions exposed as material expressions as well, which should be possible. There is precedent for that. And then if I would have to write that to a render target, that is the size of the input data, and then each pixel in the render target at the index of the input would represent something. I don't know what I should make it represent though. I essentially have a RGB, an A, or an X, Y, Z, and W. So I have 4 components, 4 float components there. What information would I pack in there? Let me think about what information I want. I would want the physical terrain material, so I would have to like correlate a number to like certain meanings. Stupid suggestion, but custom float data not your way. I'm not sure what you're asking. You're saying, I think you're probably saying, why not just use custom float data, pass it to the material? I mean, that is essentially what I'm doing, right? I just need to figure out how to get it out in a format that is useful after some calculations. I would need to come up with my own meanings for certain numbers, right? I would have to say like, okay, our channel, if it's below 0, it's, you know, underground. If it's above 0, then it's a height map. Or the difference would be like, materialize custom data float node. Yeah, I need like an array of floats, which is essentially, or I need an array of vectors, of world space vectors is what I need, which is essentially what a texture is. Like that's the material equivalent of an array of vectors. And then I need to get that data back out. I need to get some data back out And the only way I know of getting data out of a material graph is writing it to a render target. Like, there's not a way that I know of passing it or getting some custom float data out of material other than writing it to a render target. So if you know of a way to do that without a render target, let me know. Well, I guess right now, the information that I need. I have 4 values to work with. Can you get output UV data? Is that a thing? Because there's the, let me look here. Normal, isn't there, we have the material that's hit. I thought there was some material information that came from a hit trace. And I thought physical material was that, but maybe I'm wrong. Can't you get material information from a hit trace? Or am I crazy? I thought you could. Okay, ignore that. UV coordinates from a line trace. Yeah.
Tomatoes?
Why not calculate it in your computator and avoid that material will know of that data? And avoid that. I need the material to know of that data, though. So that it can represent the physical materials in the world. If you generate your terrain from computator, it looks like you can do additional stuff for another logic. Sorry if I'm completely misunderstood your problem. No, it's okay. So I could generate it from the, that was one of my options, was doing it from my computator, from like marching cubes, either voxel data or per vertex data. But that would mean that I would need to store it, right? I would need to store it, which takes up memory, takes up space. Memory is a vital resource for me because I'm going to have the world online at all times. So I need my memory to go as far as possible, which is why I'm pontificating upon whether or not I should have that that data not stored, but rather calculated when I need to, right? Because storing the per voxel data, there's a lot more voxels than there are actually things rendered in the world. So I don't technically need all of the voxel data at all times. So keeping it in memory, bit of a waste. Now, if I had my compute shaders usable as material expressions, as known in material graphs, then there would be some interoperability between what's rendered in the world and what the terrain is generated as, which would be really nice. That would allow me to generate the terrain with all this different noise, and it would allow the materials to be aware of what is being rendered, what the terrain actually is underneath each pixel or each vertex, which is going to be vital for me and important when considering terrain deformation. When I deform this terrain, I need to know if there's going to be dirt underneath this or not. And I don't want to have to store voxel data all the time, right? But at the same time, I do need the materials to be aware of that so that they can render properly. And I'm not always going to have the material rendered. Everything out here, there was no mesh here. There's no mesh. So I can't just render the material and have it work. I also need to be able to query a material as well and get output data from it. But yes, let's watch how to get UV. If I have UV data, there's a lot of output data that
and
I
welcome
can
to the video
have.
for what is the fine collision UV node. So this is the fine collision UV node, and as you can see, it takes in a hit, struct, and a channel, and then it gives us the UV based on what we hit. So if we were to run this example.
Okay, hang on. Let me see. Find collision UV. Let me see that. Find collision UV. Inverse transform position, local hit position, body setup. Okay, so you have to go through the collision. Fuck. Okay, what does this do? Maybe I can recreate this function. Vert UVs. Okay. Okay, so I have this information. I do not store UV information. That's generated on the fly when I need it. So maybe I need to store UV information as well. And then that can... Index buffer, face index, UV info. Interesting. So face index returns the triangle index. Okay. Okay. That's potentially useful. So that's how you get the material data. Okay. Now, that could be useful for me, but that doesn't exactly help me with my current problem, I suppose. Which is, my current problem now is that I'm asking, how can I get more data out of a material than just an RGBA? Because then I would be limited. I would have just 4 pieces of data per pixel as to what I can get out. And if I needed more, I would have to like, I would need another texture output. Or I would need to, like, the output data would need to be packed differently. So yeah, they're all like talking about how to get output data from like a mesh. But what if I don't have a mesh that the that it's running on? It gives me UV coordinates. But that would just equate to an index in a texture. Let me look at a texture object. So UV data is specific to a mesh, right? Like textures don't have UV data. So the question I'm asking doesn't make sense then, right? Okay, so I guess yeah, what I'm asking doesn't make sense. And there's no way to like write out UV data from a material. That would just be additional render targets, right? And so I would have to split my data calculations across different material functions if I wanted more than four, like, if I wanted more than 4 data values. I don't think I have more than 4 right now, but I think that is not enough. Use 2 textures. Yeah, I think that's what I have to do. I think that's what I'm saying. And essentially, like, I think I would need to do unspecified function. Sure. Okay. So if I would need to split it across 2 functions, right? Because I would need to know what data do the textures represent. And I would have to like, so there's going to be what, there's going to be like 2 versions of this material. There's going to be the render. Let me open up my landscape auto material here. Is this the, that's the instance. Okay, I think this is, okay, this is my landscape auto material so far. And so we're using texture coordinate, absolute world position. Yeah, so I have some material functions here already. World align blend for blending everything together. But I guess I'm going to need to reference texture data from in here. So this is going to be like the render, right? I mean, a lot of this is going to need to change too, so I can encode the data there into, yeah. So there's going to be like a render version of the material, which is honestly just going to call a different material function. That material function is going to have like multiple, depending on how much data I need, I would need to split up the data into different functions that return a texture. But for the render version, it's just one, you know, it's going to go pixel by pixel in there, and then it's going to get output. And this will be like the vertex data. And then we'll use the vertex data to determine what should be rendered. And then that's what we'll actually like use like textures and stuff for, like actual textures, not like just render target textures. And then you can't reference a material from another material. So how do you run a material? Okay, so I would need the query material that has inputs that has vertex inputs, because the render version of it is going to probably use this node or something similar. I'll have to figure out what that means, what that is, but, and that'll be my landscape auto material. It'll pass that into these functions that I'm talking about, and then the query version of the material is only ever going to be used when the mesh isn't rendered. And that's going to take an input texture that represents what this node would for the render version. Yeah, I think that could work. It's going to be slow. I wonder if I should just, well, if I just packed all that data and kept it in memory, I'm now just to storing vertex data, which I don't need the material to do that, so I can already do that. So I'm thinking about a scenario like if I wanted to like cause my entities to move slower or faster on different types of terrain. like different physical terrain materials, which is something I would like. So that things like when you place roads in your town, like that speeds up the movement and stuff. But I would basically need that data to be around all the time. That's not like one-off usage where I'm deforming the terrain. Yeah, I'm thinking maybe there is a caching system. Similar to how I cache the PCG points when I need them and don't need them. I may need to cache the Vertex data. And so maybe it is just input to a material. But the thing is, it's going to be duplicated data when it's actually rendered. Because when it's rendered, I can just get I can just do the collision hit trace thing and get what the material is representing there, what each vertex is or whatever. So, I mean, I guess I could just unload the vertex data, and there's essentially a chunk can have 3 forms of this data. One is, if it's rendered, just get it from the material with a collision trace, hit trace or whatever. If the chunk is unrendered, then it will unload the data, so no data. And then if it's unrendered and it needs to be queried, then we would load and cache the data. And we'll use an LRU cache like we do for the PCG points, so that chunks that are hotspots, they just stay in memory. If you have a colony that's like let's say you have a colony like right here, right, it's not rendered, it's right there. There's going to be a lot of colonists walking around, potentially deforming that terrain. So that data needs to be readily available. We can keep that in memory. But then what would happen when we deform the terrain and we need to get new data? We would need to rerun the shaders. We would need to rerun something. Yeah, the terrain deformation is really making this more complicated. If I didn't have terrain deformation, then it would be really straightforward, actually. So I still need output data. And it's like either I generate all of it ahead of time, even when I don't need it, so that when terrain is deformed, I do have it readily available, or I rerun the shaders. God, I suppose from this perspective, it actually seems like writing the algorithms in CPU code rather than GPU code would actually be more useful. It would be slower, but it would be more easily accessed from, for things like terrain deformation and whatnot. A lot of decisions to be made here. Yeah, I get the thing about just having, like, I know I watched a talk on No Man's Sky by Sean Murray, the guy who made it, and yeah, they store voxel data. But GPU code is cooler. I know, right? It's a lot faster too. And just saying compute shader just makes me feel like a Giga Chad. But yeah, it's there's another chatter here the other day that was like, CPP is like fast but difficult to work, inconvenient. I'm like, yeah, that's CPP and shader code. Fast but inconvenient. But yeah, I watched the talk on No Man's Sky, and they store voxel data. Ocean knew how to do compute shaders without going through Niagara. Once you get the boilerplate set up, it's not too bad. Not too bad. Just don't use structs unless you want cancer. Yeah, don't use structs and shaders unless you want cancer. And certainly don't pass 8 neighboring noise parameters so that you can do a weighted average blend between them. Don't do that. Wouldn't recommend it. And then yeah, here's me trying to encode curve floats. I just sample 200 points on each curve float and then pass in a float buffer. Inconvenient. Inconvenient. But yeah, No Man's Sky, they use voxel data, but like, I either need to just store all of the voxel, generate it ahead of time, and store it. Keep it in memory. Yeah, there's that shade up tool. It doesn't work though, it's out of date. So you can use that to get a starting point, what Yili linked. I have used that as well, but it doesn't work. It doesn't work out of the box anymore, so it's not updated. Let me show you my... Yeah, this is what I copied from. This also doesn't work out of the box, but that's where my marching cubes implementation came from, largely. It's kind of a Theseus's boat paradox at this point. I've modified it quite a bit, but that is personally where I've started. You can also use that shade up as well for the boilerplate, but like I said, you'll need to figure out why it doesn't work. I can do probably a brief overview. My shaders library. Okay, so, and let me do compute shader processor as well. So how you like execute a shader is that you have to enqueue a render command. You have to use this macro right here. And so that's how you kick it off onto the render thread. And I don't think compute shader relates to anything. I think that's just like some sort of identifier. But then you give it the lambda, and then in the lambda you get this RHI command list. I create, they call them GPU fences, and this is what you can use to await the result of your compute shader. You can also flush rendering commands. That will do the same thing, except it will block the current rendering frame. So until all of the current commands are done executing. So I rather just use a fence, and then I wait for the fence to be completed. I launch a background thread, and then I do this to wait for rendering commands to finish. That way it's a little smoother. And as far as what is the actual compute shader, you take this RHI command list, and I'm passing it into these different functions. We'll look at marching cubes. So this RHI command list, you have to use this to create this FRDG graph builder thingy. And this graph builder is how you like wire up all the input and output data that you need. And so you have to use these create structured buffers. And this is for like, and you have to know what the data type correlations are, right? Like a f vector 3f, that is a float 3 array in a shader. So if we look at out vertices here, f vector 3f, that relates to this out vertices here. And the way that you define that pairing is with these parameters, right? So you also have to define, look at this, you also have to define this file, which is like, this is like the CPU version of your shader. And so you have to do this macro implement global shader, passing it this class name. that's in the header file, and then the path to your shader, and the entry point function name, March, so that'll relate to this one at the very bottom here. Yeah, March right here. So that relates to this. And then you have this SF compute for what type of shader you want. I think you can do like Vertex and like pixel shader and stuff as well. So you define that in the CPP file, and then that, I guess, just kind of like automatically gets wired up into here. But then you need to use these macros to define your parameters that are going into the shader and out of the shader, right? So I was talking about that float3 array. So if we look at, let me go back up here. Yes. Okay. So I pass in like out vertices, right? And so we're going to take this out vertices and we need to create a structured buffer. And when you want output data, you need create UAV. UAV is uniform access view or something like that. And that's output data or an output array. An input array is an SRV. So you have to create the two different ones for input and output data. But eventually, this out vertices UAV, we use the out vertices. You have to allocate how much you want out, like the number and the data size, and you pass in that buffer to. I'm just using another function for this, but you have to put that onto this out vertices that is defined here. So this is like I said before. This is where you're defining your parameters. And so everything in here gets represented in the compute shader when you actually run it. And so finally you need to add this pass, and you need to pass in like the thread count, like how many threads you want this to run on. And for marching cubes, each thread ID, which is an X, Y, and Z, represents a vector in world space for me. So in my marching cubes, this thread ID is actually the vertex, is what I'm using it for. And yeah, so each one of these represents, you have to define them in their shader equivalent code at the global level of your shader. The gold mine of info. Do you save your VODs? Yeah, they should be. I don't know if all of them are on Twitch, but all of them are on YouTube for sure. But yeah, I went through the struggle of figuring out this boilerplate, so you don't have to. And then after all that's done and ready, you've got you need to define your input function with your thread ID. Num threads here should relate to what's here. My face is in the way. Hang on. There you go. It has to relate to here. This is your thread count. And then you need to make sure you define all your input parameters as well in their equivalents. Like an int3 is an f int vector. Float3 is an f vector 3f. Float's just a float. That's a one-to-one. Int is a one-to-one as well. That's just the same as an int. What else can there be? Yeah, and then there's structs as well, but like that's just a whole fucking headache. I would not recommend passing in structs. And so here's what that looks like if you're daring. Oh no, this is the wrong file. Hang on. That's in my... Oh yeah, and you have to put them in a fucking plugin. I forgot about that. You have to create a plugin for your shaders. And I think this is important. These are important for some reason. I forget why. But I think you need the loading phase to be set specifically. And I think that Shade Up website will signify that as well. But then, yeah, you have to structure them specifically as well. So I think the Shade Up is a good place to start. But the way they like extract their data and stuff is a little different. And I don't think it quite works. Yeah, I guess the only other important thing is to get data out. Like you add the graph pass. This is like the actual execution pass here. But if you want output data, you have to add this extract buffer pass, this is a built-in function. No, it's not. It's my own function. I lied. Okay. I don't even know how they work, and I wrote them. Here's how you're using another graph builder add pass, I presume. Yeah, just screenshot this. This is how you get data out of a compute shader. I guess there's a memory mem copy here. Yeah, I guess this is a specific thing you gotta do here. Yeah, I guess you have to lock the buffer, copy the memory over, and then unlock it, I suppose is how that works. But yeah, if you want data out, you gotta extract. You gotta add one of these extract pass thingies. And then yeah, if you have a struct that you're trying to pass, like there is these different macros, right? And if you have a struct you're trying to pass in here, it's absolute garbage. Do not recommend it. Okay, shader parameter struct. There's a macro for that and a struct array. But you need a struct that you define as a parameter here. You need a struct that is defined in the shader file, so the shader equivalent of it. And then you also have like whatever struct this is coming from on the CPU. So there's like literally like 3 fucking different forms of the struct. And then the way it's represented in the shader is like the most unhelpful thing, which is why I did all these macros. And so the expansion preview here, like if I passed in the cheese noise params, which is here, it's a single struct of f noise param. There is no struct equivalent in here, right? So it creates these variables here, and so the variable names are the name of the parameter here, so cheese noise params, underscore, and then the member, and then you have to make sure the types line up. And then for me, I'm using, like, I need a noise function. Do I have noise functions or something? I have a noise function. Utils? No. Noise generator. Isn't it here? Get noise value up position. Oh, it's in gener. Okay, here we go. So I have this function. It takes in a struct. Now this struct is the shader version of the struct up here. But because of how these like get expanded and passed into the shader, I have to wire it up manually so that I can pass it into this function and use it for all my parameterized noise. And that's why I have that's why I have all these god-awful macros here. This is me manually wiring up the passed in struct parameter to the actual shader version of the struct. And because I have a struct array for all my neighboring chunks who have different parameters of noise that I need to blend between, I have to do this 8 times. So yeah, that's all my compute shader knowledge dumped in one totally understandable and unambiguous form. I have a meeting I have to get to soon though, which would be nice to just skip. Yeah, they are a nightmare, but I think it was kind of like my only option to be able to work with it. Like, I think the only other options are worse than what I have here, unfortunately. I guess I could have just passed in the values. I would have needed an array for each value within this struct. So an array of f vector 3, an array of, see, but here's more nested, like I would need an array for each one of these things. So it's like, is that better? I don't know. An array of scales, an array of qualities, an array of functions, turbulence levels, min, max. That was the other option. And I don't know, that doesn't sound as great. And then any time that I want to reuse that noise function, I need to, again, wire up. Thanks for the sub, my dude. I appreciate that. Each time I want to reuse this noise function, which I use it in several places, I would need to rewire up all those arrays of things. So I don't think there's a great way to do it, honestly. But that's just kind of the nature of working on the GPU. Thanks for sharing. Yeah, absolutely, my dude. More than happy to clarify anything or answer questions. Yeah, anything else I want to say there? Oh yeah, there's a max thread count. What is it, like 1024, I think? Depends on the GPU, I believe. But there's a max thread count. So 888 is like the highest number you can use for, like, if you need X, Y, and Z to be equal, 888 is the highest. But I think you can do 1616.1, and that will give you more threads. Oh, 3232.1. That's what I use for a height map, because my height map is 2D, so I don't need the third component. So you can do 3232.1. But if you need an X, Y, and Z, 888 I think is the highest you can do. I think that's pretty much everything. I have this like compute shader processor that I wrote, and it's just like a little subsystem that when the game is running, like at runtime, I'm only running one shader at a time, and they get queued up, and that way it keeps the rendering nice and smooth, or attempts to. But when we're starting the game for the first time, I want to get the world generated like as fast as possible, so I just run as many as possible here. So this compute shader handles in queuing each different compute shader that I have with some instant struct data, and it'll call back to, it'll use a delegate to call back to whoever scheduled it to let them know it finished, and that way it handles all like this in queuing, and because I was doing this like only in the places that needed to call it, and it was just getting messy, like so many callbacks and delegates and stuff. So I just kicked it off into its own subsystem to handle, which had its own issues. Any chance you know how to create a custom render pass, kind of like the translucency pass, but a custom one? Yeah, all that rendering stuff is completely over my head. Yeah, I don't know very much about rendering. Like, I've been a software engineer for like 10 fucking years, but I know nothing about game dev rendering. But I'm sure the answer is something along the lines of graph builder add pass. Skip render pass? I don't know, you can skip it. So I'll see if these video about how the render clouds, and always wondered how it's done. Do they use Unreal Engine for Sea of Thieves? So you can skip render pass. Only valid when combined with raster. Disables render pass merging for the pass. Raster uses rasterization on the graphics pipe. Yeah, UE. Oh, they're using UE4. Old Faithful. Pass will never run off the render thread. There is on that RHI command list, there is a begin render pass function. Let me guess, there is no comment for it. Oh, yeah, there's not. It's inline. The context RHI begin render pass. Cache active render targets. And there's an is inside render pass. Persistent state inside render pass. So yeah, it looks like there is some level of access. I'm sure there are just like a ton of caveats. But it looks like there is a way to like Begin render pass. Render pass info. What is that? Yeah, so it looks like there is a way to do the render pass, and I have no idea what this data represents, but it's there. Yeah, you'll have to report back with anything you learn. I'd be interested to know more things. Whizzle is my new favorite word. Look at that. Whizzle. Whizzle me timbers. Okay, I gotta hop off and get to a meeting here in a little bit. Actually start my workday. Let's send you guys over to Odd Oculus. The homie Odd Oculus. But yeah, thanks everyone for stopping by. Sovereign, appreciate the sub, my dude. Yeah. We did things today. I feel like I have somewhat of a direction for my Vertex / Voxel data. A lot of things up in the air for me though that I need to figure out. Good stream. Thank you guys. Thank you. Yeah. Thanks for hanging out. Thanks for joining me. Hopefully we'll see you guys later. Probably won't stream till this weekend, but it should be a good long stream. So yeah, thanks for stopping by, guys. Later.